Now, in order to understand series and parallel connection further, let's take this question. Two resistors, 5 ohm and 10 ohms, are arranged first in series and later in parallel to a 24-volt source. The ratio of total power dissipated in the series and parallel arrangements, respectively, is. So, what they are asking us to do here is to calculate the power when these resistors are connected in series, and also calculate the power when they are connected in parallel, and then find the ratio of the two. So that's what we're going to do now. So before we do that, okay, let's first sketch the first instance. First, we have our R1 here to be 5 ohms, and our R2 to be 10 ohms. And then our voltage V, or EMF source, or EMF, equals to 24 volts. So the first instance is first arranged in series. So let's do a series arrangement. So if I sketch, this is the first resistor connected in series with the second resistor. So this is 5 ohms and this is 10 ohms. And then they are connected to a 24 volts voltage source. So I could put my voltage source here, or I could just draw it down. Positive, negative. So that's how to do it. 24, sorry, not 12, 24 volts. So I've sketched the diagram. This is for the series connection. So let's calculate the total power. Now, power is defined as what? The rate at which energy is consumed, where W represents energy, T represents time. And then this same power, energy itself is what? Charge times voltage. Then still over time. And then charge itself is what? Current times time. Then this voltage still remains over time. So time will now cancel time. So we have what? Current times voltage. So the formula for power is also current times voltage. That's why you see high tension power, they're always rated in kVA. K there represents kilo, V there represents voltage, A there represents ampere. So that's the unit for power as well. However, what the parameter we have here is voltage and resistance, not current. So if we are to use this formula here to find power, that means we are going to first calculate the current. But instead of stressing ourselves, current can be defined as what? Voltage over resistance. Remember, Ohm's law states that a voltage equals to what? Current times resistance. So if you make current the subject, that will be what? Voltage over resistance. So if you substitute it here in place of that, you now have V times another V over R. So that power will be given as what? V squared over R. So you just need to know how to play around these definitions and mathematical expression in order to answer questions. So this is the formula I'm going to use to calculate the power. So let me calculate the power for when it is in series. Now, this R here represents our equivalent resistance. So equivalent resistance here, R equivalent, equals to, since this is a series connection, the resistors will add up. There's not much mathematics there, so that will be 5 plus 10 to be 15 ohms. So R here will be equivalent resistance, because we are trying to find the total power, not individual power dissipated in the resistor, the total power drawn from the source. So our P now, P series, that's the power in the series connection, will be V squared, which is 24 times 24 divided by by R. Our R is 15. So if we are to reduce that, 3 will divide there, 5. 3 will divide here, 8. So we have 24 times 8 divided by 5. This is what? There is a reason I don't want to finish the division and convert this thing to decimal, because in most exams you are not allowed to use calculators, and then for this particular exam JAMB, the calculator you are given is not a type that will encourage you to do this, because if you do this you end up having decimal and there is no decimal number in your option, so you will not know the option to choose. We don't use decimals in ratio, in expressing ratio. Okay, so I leave the answer here, 24 times 8 divided by 5. That's what? That's my power when it is in series. So the next one I'm going to do the analysis for a parallel connection. I'm going to do the analysis for a parallel connection. So let me do my parallel connection there. This is my first resistor, and this is my second resistor. So you see now, this is a parallel connection. Both of them share the same terminal. They share the same terminal, this terminal and this terminal. So connected to a 24-volt source. So this is my 5 ohms, and this is my 10 ohms, and this is my 24 volts. So let me analyze the parallel connection. Now we'll still make use of this same formula for power, but the only difference is that we are going to, the value of our equivalent resistance will change. So when two resistors are connected in parallel, equivalent resistance can be given as what? R1 times R2 divided by R1 plus R2. So that will be 5 times 10 divided by 5 plus 10. 5 times 10 is 50. 5 plus 10 is 15. If we reduce that, 5 will divide here 3. 5 will divide here 10. So we'll be having 10 over 3 ohms. That's about 3.3333 ohms, but I'm going to leave it in fraction because I don't want to deal with decimals. This helped me to work efficiently even without calculator so that I can get my answer correctly. So now for me to calculate the power for parallel connection, P subscript P, and our formula still remains the same, V squared over R. Our V is 24 times another 24 divided by R. Our R is 10 over 3. So if you process this further, this 3 will go to the numerator. You have 24 times 24 times 3 divided by 10. Divided by 10. So if you reduce that a bit, okay, let me still leave it there. What? So now I've calculated my power for series connection, and I've also calculated my power when it is parallel connection. So now let me take ratio of the two. Let me take ratio of the two. So now ratio, which is what? Power for series connection is to power for parallel connection. This will be equals to, for series, what did we have? 24 times 8 divided by 5 is to this one. What do we have? 24 times 24 times 3 divided by 10. So basically all these are division. So let's start cancelling out. This 24 here will cancel out 24 here, cross multiplication or divide both sides, whatever. Cancel there. 8 will cancel itself 1 and cancel 24 here 3 times. So what we have here? We have 1 over 5 is to 3 times 3, 9. 3 here times 3 here is 9. Is to 9 over 10. So 5 will cancel itself 1, cancel 10, 2. I hope you understand that if you do cross multiplication, 10 will go to the numerator, 5 will cancel it 2. So we are now left with what? 1 is to 9 over 2. And of course, cross multiplication will make this thing become 2 is to 9. So our answer of power dissipated for series connection, the ratio of power dissipated series connection to that of power of parallel connection is what? 2 is to 9 or 2 to 9. So this is the answer. So let's go to our option and see what we have there. So our option says 5 is to 3, no. 1 is to 50, 50 is to that, 3 is to 5, no. E, no correct option. So me, I'll go for E. You have to be confident in what you do. That's what science is about. So basically, this question is just to drag out your time to see whether you have any basic understanding. I know some people say, the answer, there must be an answer. No. With conviction, there is no answer there. My answer is not that there is no answer to the question. The answer to the question is 2 is to 9. That's the ratio, but it's not in the option. So the correct option is what? E, no correct option. Thank you.